Welcome back to another instalment of New Zealand Bird of the Week, where in this video I will be talking about the kakapo, a species of parrot that with its unique appearance and behaviours is one of the most interesting birds anywhere on Earth. I hope you enjoy. Kakapo are very strange birds. Their biology, appearance and behaviours that I will get into later really are unlike any other bird and makes them a very endearing species. Kakapo, meaning night parrot, are a species of large, flightless ground-dwelling parrots that are endemic to New Zealand. First described by Europeans in 1845 by ornithologist George Gray, the parrot was given the scientific classification of Strigops habruptilius, the genus name meaning owl-face through its close resemblance to the unrelated owl's distinctive facial discs. The birds were noted to have many unusual features, and so they were initially placed in their own tribe, Strigopinae. Recent phylogenetic studies have confirmed this unique position of the genus, as well as its close relation to the kaka and kea, both belonging to the parrot genus Nestor. Together, these New Zealand parrots are considered to be in a separate subfamily within the parrots, Strigopoidea, the most basal of all living parrots. Within this subfamily, the kakapo is placed in its own family, Strigopidae. The common ancestor of the kakapo and the genus Nestor became isolated from other parrot species when New Zealand separated from Gondwana around 82 million years ago, the kakapo diverging around 30 million years ago. Early ornithologists noted that the kakapo may have been related to the ground and night parrots of Australia due to similar coloration, but this has been thoroughly contradicted by recent studies, and the cryptic coloration is merely a convergently evolved trait. The mottled greens and yellows helped the kakapo in keeping camouflaged while on the ground, keeping itself out of sight from the haast eagle and other aerial predators patrolling New Zealand's skies and canopies. Kakapo have also been noted to freeze when in danger, and in turn blend in near seamlessly into their surroundings. Before human arrival in New Zealand, there were no land-dwelling mammals on the main islands, save for bats. And so, in this absence of any competition, the kakapo, following a great many of other native birds, became flightless, and is the only known parrot to have done so. Given its flightlessness, kakapo wings and tails are noticeably more stout when compared to other birds, possessing a diminished keel on the sternum where flight muscles would otherwise have attached. The bird's wings aren't entirely useless though, as when foraging, kakapo have been noted to use their wings for balance when running and to lean on branches, as well as flapping vigorously when leaping from trees, cushioning their falls. Because of ground-dwelling habits and lack of competition, kakapo are large birds and can measure 58 to 64 centimeters in length and have an average weight of 2 kilograms for males and 1.5 kilograms for females, although some larger males can reach up to 4 kilograms, with males generally weighing 30 to 40% more than females. Because of their flightless biology, kakapo have strong legs and feet and have an enlarged pelvis to hold up their large bodies, with the legs being stouter than in other parrots, but compensating with their large feet, which, as in all parrots, are zygodactyl, meaning that 2 toes each face forward and backwards, allowing kakapo to grasp onto branches as they amble up for food. Due to their ground-dwelling nature, kakapo tail feathers, which are decurved due to the position of their tail, are often worn down from being continually dragged on the ground, giving them a more tattered look in this region. Another remarkable feature of kakapo is that they are nocturnal, an adaptation to avoid their diurnal predators. The optic tectum, nucleus rotundus and entopallium are smaller in relation to its overall brain size than those of diurnal parrots, but they make up for this with a large olfactory bulb ratio, which indicates that their sense of smell is more developed than other parrots, in this way being more similar to mammals, which generally utilise their sense of smell to locate mates and prey, unlike birds which are usually the opposite, having exceptional eyesight and a poorer sense of smell. This heightened sense of smell allows the kakapo to forage in peace at night, giving it an opportunity to locate fruits, seeds and other plant materials for it to eat. Although being able to avoid diurnal predators, the nocturnal ones are still present, and in the past, when laughing owls were still plentiful, they would have been preyed upon by these large predators, and, as evident from owl nest deposits on Canterbury limestone cliffs, kakapo were among their preferred prey. One of the most interesting aspects of kakapo behaviour is that they are the only parrots to practice a polygynous lek breeding system. Male birds loosely gather in an arena and compete with each other to attract females mating with one male, while the males mate with numerous females. The females choose a mate based on the quality of their display, but they do not form a pair bond, and male and female birds only meet to mate. During the courting season, kakapo males leave their home ranges for hilltops and ridges where they can establish their leks. These leks can be up to 5 kilometers from a kakapo's usual territory and are on average 50 meters apart within the lek arena. At the start of this breeding season, male birds try to secure the best areas for displaying, often confronting each other with raised wings to make themselves look larger, as well as screeching and growling, with fights often ending in injuries or even death, with one bird, known as Arab, nearly losing an eye in the process, something that is hard to imagine when the birds themselves look so unassuming. In each of their own courts, male kakapo creates one or more saucer-shaped depressions or bowls dug into the ground, which can be up to 50 centimeters deep and long enough to fit in the whole bird. These bowls are connected by a network of trails or tracks which may extend to upwards of 50 meters along a ridge or 20 meters in diameter around a hilltop, changing the forest floor in the process. Kakapo males meticulously clear their bowls and tracks of debris on a routine basis, removing twigs that are placed by researchers and tossing them away with their beaks. Over many years, these track and bowls, of which a male may use 2 or 3 at a time, develop to become notable landscape features. In pre-human New Zealand, these track and bowl systems were probably inherited by generations of males, and the abandoned Fiordland systems are still visible more than 20 years after they were last occupied. When contacting mates, male birds make a distinctive booming call for 6 to 8 hours every night for more than 4 months in the breeding season. Birds puff themselves up through an internal thoracic sac located in their chest region, which can be filled with an intake of air to produce their deep sounds. This boom resonates at less than 100 Hz, which for a frame of reference, a human ear can pick up sounds within the range of 20 to 20,000 Hz. From within a few hundred meters, the sound has been recorded to be almost felt as much as it is heard, and from a distance of up to 5 kilometers can be difficult to pin down where it is coming from. Low-pulsed sounds like these are best for travelling great distances due to a shorter wavelength, allowing the sound to better travel at ground level through dense forest. This booming also has another advantage in that on islands like Whenua with large populations of vocal seabirds, the low booming call of the kakapo is at a different bandwidth to these birds, allowing its noises to still be heard by other kakapo even with all the extra background noise. The bowls themselves are often created next to rock faces, banks or tree trunks in order to better reflect sound, the bowls also functioning as an amplifier, showing that the kakapo have the intelligence to utilise their environment to have the best chance possible to attract mates. Alongside booming, kakapo also produce a higher pitched, metallic call known as a ching. This rapid chinging call is strongly directional and can clearly advertise where a male is, and carrying up to a kilometre away, presumably helps female birds hone in on the male of choice once their initial booming is heard. The kakapo's facial discs also act as a radio dish, which due to its shape allows sound waves to be directed towards the kakapo's ears, allowing it to more easily detect where other kakapo are located. Birds also have a variety of other calls, including a deep snark, which is one of the more common noises the birds produce, even though they are relatively silent outside of breeding. Kakapo, on occasion, do make other noises as well when in close proximity to other birds, including pig-like grunts and squeals, duck-like walks, and donkey-like braying. Interestingly, younger, more inexperienced males appear to deliberately choose to join a lek of successful males, perhaps hoping that their success will rub off on themselves. Kakapo males during breeding have been documented as so overwhelmed by their raging testosterone that they will attempt to mate with almost anything and everything. Fiordland males were observed to mate with rolled up jerseys that were put into their bowls by wildlife officers, who themselves were often subject to mating attempts. On Hauturu, the corpses of dead seabirds such as Cook's petrels at Kakapo track and bowl systems is evident that male Kakapo are aggressive towards trespassers. One bird, after killing a petrel, continued to mount and mate with the body for several nights, apparent of the Kakapo's desire to mate. The reasons as to why Kakapo would have evolved a lek breeding system comes down to resources. Kakapo eat a great variety of low-energy plants, so there is no concentration of vital resources to be defended. A female is also able to nest and raise chicks on her own in the years when there is an abundance of these foods, and therefore doesn't need a male to assist her. It also means that the most impressive of birds gets to pass on their genes, meaning that future generations of Kakapo are more likely to inherit a dominant male's genes, with some birds getting a considerable amount of mates, while others remain unsuccessful. The unusual breeding system of Kakapo is possible only because there is a third player in the process, that being a few species of mast seeding trees, which kickstart Kakapo into breeding mode at infrequent intervals. Mast seedings occur every few years, and during this time, many species of plants produce a large amount of fruit and seeds, which are a bounty to many native animals, and especially the Kakapo. There are a number of reasons why Kakapo have tied their breeding success to Rimu and other plants, is since that the birds don't breed every year. The Rimu gives them an external mechanism to synchronise their own efforts with their own, ensuring that the birds know when it is the best time to breed. This also ensures that there is a good, long-lasting supply of food for sustaining themselves during breeding, and for females to sustain their chicks. Because chick rearing is such a demanding task, female Kakapo often need a year off to recover. The irregular nature of these mast years also ensures that Kakapo nest regularly. Kakapo are also some of the oldest lived birds, and birds are theorised to reach around 60 years on average, and are even capable of surpassing 100 years in age, and like the Rimu, have time on their side, and so there is no need to breed every year. It isn't yet known how exactly Kakapo perceive that Rimu are about to fruit, but one potential explanation could be a hormonal cue, related by the production of chemicals such as gibberellins, with Kakapo being exposed to the chemicals when they eat part of the tree, either the foliage or the developing unripe fruit. The hormones in Rimu that trigger Kakapo breeding may be phytoestrogens, which supplement the female's estrogen levels. High levels of phytoestrogens have been identified in Rimu and other native tree fruits, and that New Zealand parrots have a unique sequence of 8 extra amino acids in their estrogen receptor gene, which may make them more sensitive to estrogen. Kakapo aren't entirely reliant on Rimu though, as in areas where they are not present, Kakapo breeding would instead be triggered by plants such as snow tussock and southern beech, although Rimu still has incredible benefits for Kakapo breeding. Rimu fruit contains a good amount of protein, essential fatty acids such as palmitic, as well as being high in vitamin D and calcium, alongside carbohydrates and sugars. Although the protein levels in Rimu aren't something to write home about, at around 7.4% in ripe fruit, it is nonetheless better than what Kakapo regularly eat. The high levels of calcium in Rimu have also been found in a recent finding to be key in the production of eggshells, which female Kakapo would not normally be able to acquire so easily otherwise, and is an important part of a diet which otherwise offers little in the way of high quality foods. Kakapo are one of the few birds that can accumulate body fat, and can also increase their weight by 100% prior to breeding season. Such fat reserves may also aid in thermoregulation in cold temperate climates, particularly in the subalpine region of Esperance Valley in Fiordland, where the mean annual temperature is 6 degrees Celsius. The low metabolic rate of Kakapo means that birds need to spend little in the ways of energy, and can therefore survive off of low nutrient plants without the risk of starvation, and therefore can spend more energy in competing for mates and maintaining their track and bowl systems, meaning that they need to expend very little energy. The levels of vitamin D, as mentioned, are also very high, and are so high that the 500 or so grams of rimu fruit eaten by a Kakapo chick would contain more than 30 times the recommended daily amount of vitamin D for a much larger human, yet alone a Kakapo. But paradoxically, adult Kakapo have negligible amounts of vitamin D in their bloodstream, around 25 nanomoles a litre, which is considered pathologically low in other bird species. Chicks given supplementary food to assist in their development, which have higher levels of vitamin D, have higher amounts of vitamin D in their bloodstream, but it's not yet clear as to whether these birds are just naturally deficient, or that the supplementary findings are a good thing or not, a puzzle which will hopefully be solved as our understanding of Kakapo develops. The only downside to these superfoods is that rimu crop often fail to ripen, and when this does happen, it spells certain disaster for the breeding season upon which the failure occurs. When this happens, birds go through a slow disintegration of their breeding efforts. As the females struggle to feed themselves, they leave their chicks and eggs alone for longer and longer periods to find food, increasing the chances that chicks will either become chilled, succumb to infection, or starve to death. Before human arrival in New Zealand, such events wouldn't be too huge of an issue, as if Kakapo can live between 60 and 100 years, and rimu trees for many hundreds, then an individual bird would only need to breed successfully once or twice in their long lifetimes to pass on their genes and the survival of their species. But since their numbers have catastrophically dropped since then, the importance of mast years have become critical to ongoing Kakapo conservation efforts. Female Kakapo lay between 1 and 4 eggs per breeding cycle, with several days in between each individual egg. Birds nest on the ground and under the cover of plants, rear their young, although burrows and hollow tree trunks are also utilised. They incubate the eggs as often as they can, but are forced to leave them every night in search of food to sustain themselves. This leaves the eggs vulnerable to the cold, and embryos have been known to die in this way. The chicks hatch out of their eggs within 30 days after being laid, bearing fluffy white plumage and being completely helpless in their first few weeks. After the chicks hatch, the female feeds the chicks for the next 3 months, the chicks remaining with the mother for a few months more after fledging. Chicks leave the nest at approximately 10 to 12 weeks of age, and as they gain greater independence, their mothers may feed the chicks sporadically for up to 6 months. An interesting aspect of the Kakapo's breeding system is that a female can alter the sex ratio of her offspring, depending on her condition. A female in good condition produces more male offspring, as birds produce offspring biased towards the dispersive sex when competition for resources, such as food, is high, and towards the non-dispersive sex when food is plentiful. A female Kakapo will likely be able to produce eggs even when there are few resources, while a male Kakapo will be more capable of perpetuating the species when there are plenty, by mating with several females. The relationship between clutch size ratio and maternal diet therefore has conservation implications, because a captive population maintained on a high quality diet will produce fewer females, and therefore fewer individuals valuable to the recovery of the species. Before the arrival of humans, Kakapo were distributed throughout both main islands of New Zealand, being one of the most common species in the country. Birds lived anywhere from subalpine tussock lands, coastal areas and podocarp forests, being what is known as a habitat generalist. While now being confined to islands free of predation, they were once able to live in practically any climate and environment present in New Zealand. Unfortunately, their bountiful land was soon to be invaded by new colonisers, and with them would be the harbourers of the Kakapo's brush with extinction. Around 1280 AD, Maori arrived from Polynesia into New Zealand, and bringing with them Kiore and dogs, Kakapo now faced ground-dwelling predators which they were not adapted to deal with. As well as new predators, Maori also cleared much of New Zealand's forests in the process, clearing out vast swaths of the east and south island especially, likely causing them to go locally extinct in many areas, with forest cover diminishing from 85 to 53% by the time Europeans first arrived en masse in the 1840s. After the large moa were wiped out and seal and sea lion populations diminished, Maori turned towards the Kakapo for food, utilising their dogs to hunt down Kakapo, not just for their flesh, but their skins and feathers, which were often made into exceptional cloaks and headdresses. Over time, Maori began to incorporate a conservation ethic to preserve what was left, and while still hunting birds like Kakapo and Kereroo, had less and less of an impact on the country as time progressed, even though they were still threatened by introduced rats. Kakapo continued to survive in large numbers up until Europeans arrived, and were still locally abundant throughout the west and southern parts of the South Island, as well as in the central North Island. The Kakapo became a tauanga or treasured species, and became well respected, considered to have a special wairua or spirit. When Europeans arrived in New Zealand, Kakapo numbers had by this point diminished, but were still very common around the country. Charlie Douglas, or Explorer Douglas as he was known, wrote about the birds and their presence in the country, and had this to say about them. At one time, Kakapo swarmed in that birch country from the sea beach to near the snow line, and in 2 instances I have caught them on snowfield as they were trying to cross the divide. They could be caught in the moonlight, when on the low scrub, by simply shaking the tree or bush till they tumbled to the ground, something like shaking down on apples. I have seen as many as half a dozen Kakapos knocked off one tutu bush this way. The birds used to be in dozens round the camp, screeching and yelling like a lot of demons, and at times it was impossible to sleep for the noise. The dog had to be tied up, or matters would have been worse. It would have been fetching all night long, but alas, this is a thing of the past. There wasn't a bird to be found unless by going high up on the spurs. Like the Maori, Europeans also ate kakapo, and being as good as any barnyard fowl, with a strong and slightly stringent taste. But this was the least of the kakapo's worries. When European colonisation went underway, up to 8 million hectares of native forest were completely destroyed through devastating fires, to open up areas for farming and development, largely up to a moral aspect, first driven by the Christian imperative to restore the landscape to an Edenic state from the wilderness created by the sins of man. For these people, recreating Britain, the familiar landscape of home, was of top priority, and the destruction of the native environment was seen as inevitable and was made to be subdued. Today, the impacts of these great and incredibly efficient fires are still felt. Only around 24% of native forest remains, a lingering remnant of the once 85% forest-covered pre-human New Zealand. As well as this, cats, pigs, possums, deer and rabbits were all introduced and had a devastating impact on the environment and the animals that lived there. But the most devastating of all came in the form of the Norway and brown rats, which outcompeted the Kiore and became an even more formidable threat to eggs, chicks and juvenile birds. By the late 19th century, Kakapo became well known as a scientific curiosity, and many birds were captured and killed for their skins for museums and collectors, as well as for zoos, although most captured specimens died within months due to a lack of understanding of how to look after them. From the 1870s onwards, Kakapo numbers had continued to decline, and at this point the concern was that the species would be going extinct, and so as many specimens were needed to be collected as possible, and thousands of birds were collected for museums all across the world, furthering their decline. In the 1880s, when rabbit populations had reached plague levels due to unregulated breeding and lack of predators, it was only then that the farming economy that the government depended on decided to act. But instead of eliminating animals, it was decided to import weasels, stoats and ferrets to deal with the rabbits, a decision that was contested by pioneering conservationist Richard Henry and others like him who knew just how disastrous this decision would be for the native wildlife, and especially birds like the kakapo. Their lobbying was ineffective against the powerful farmers groups, and mustelids were set upon New Zealand. While they did target rabbits, they were not their preferred prey, as eventually these predators began to take more notice of the more vulnerable and easier to catch native fauna, which proved disastrous for kakapo. Mustelids like stoats often kill more than they need to, and therefore whole populations of kakapo were quickly wiped out. The main kakapo strategy of remaining motionless unfortunately proved useless against mammalian predators, which operate more on hearing and smell than on sight. When confronted, kakapo freeze, and in an anthropomorphic sense had an innocent incomprehension of what was coming their way. Brooding females often let human researchers handle chicks and eggs while they are present, and for the birds, there was little chance of escaping. In the breeding season, Kakapo booms and chings are great for alerting these introduced predators due to the distance from where they can be heard, and their distinctive musty sweet odour, which has been described by some as akin to an old clarinet case, did little to help their cause either. Kakapo are large enough to theoretically repel an attack, but simply lack the necessary instincts to do so. By the mid-1890s, Kakapo became extinct in the North Island, and had also begun to decline and disappear from their South Island strongholds as well, from the west coast, northwest Nelson and southern Westland. It wasn't long before Kakapo were restricted largely to the inaccessible areas of Fiordland and in parts of Stewart Island. The imminent extinction of Kakapo did not go unnoticed, however, as previously mentioned Richard Henry sought to preserve the Kakapo and other native birds like the kiwi, and being the caretaker of the now reserved Resolution Island, Henry began catching and transporting more than 200 Kakapo from the mainland to the island in a small rowing boat over the course of 6 years, safe in his knowledge that mustelids could not reach the island. Sadly, Henry underestimated the swimming ability of the animals, and stoats managed to reach the island by 1900, wiping out the Kakapo population within 6 years. After this, large-scale conservation efforts like this ceased, and as sightings of the birds became rarer and rarer, for the next half-century had effectively disappeared, and in many people's minds they were already extinct. In the 1950s, the newly formed New Zealand Wildlife Service was established, and began to make regular expeditions to search for the Kakapo, mostly in Fiordland and what is now the Kahurangi National Park in the northwest of the South Island. Finally, a bird was found in 1958 and was measured and photographed, confirming that Kakapo was still an extant species. 5 more birds were caught in 1961, and in an attempt to establish a captive population, were transferred to what is now the National Wildlife Centre. The generally solitary birds became stressed when kept in close confinement with other birds, and it was soon clear that the attempt to captively breed Kakapo was a failure and not suitable for the species. Up to 60 expeditions were mounted to look for Kakapo between 1958 and 1973, and it was beginning to be clear that Kakapo were declining. In 1973, the Kakapo program took on a new lease of life, when responsibility was handed from the Wildlife Division's Research Unit to the Protected Fauna Section led by Brian Bell. Assigned to lead the field programme was Senior Protected Fauna Officer Don Merton, who had already led highly successful efforts in translocating North and South Island saddlebacks to evade their extinction, and would go on to do the same with the black robin. The field programme was embarked with a sense of urgency, realising that to have any chance of saving the species, female birds needed to be found, as well as being transferred to island sanctuaries. From 1974 to 1978, a total of 18 Kakapo were discovered, but all were males, raising the possibility that the species was functionally extinct. In order to preserve the Kakapo, an expedition to Stewart Island, the last feasible place that Kakapo could be found, was undertaken. Thankfully for the conservation team, many Kakapo were found on Stewart Island in 1977, and at an estimated population of between 100 to 200 birds, was a substantial increase in total numbers, but most importantly, female birds were also present. But alongside such exciting findings, a more sinister series of discoveries were also being made. While mustelids had never colonised Stewart Island, feral cats were present, and during the survey were killing Kakapo at a rate of 56% a year. At this rate, the plan to move Kakapo to offshore islands was becoming more urgent, but until that point, the only island suitable for transfer was Maud Island, where the last surviving Fiordland Kakapo, Richard Henry, was relocated. The island of Hauturu, or Little Barrier Island, was ultimately deemed as safe enough for relocation, although the presence of rats would be a great hindrance, and the birds were also relocated to Codfish, Mana, Anchor and Chalky Islands. Between 1982 and 1997, all remaining Kakapo were moved off of Stewart Island, and in the end 62 birds had been saved from certain extinction, and the whole species had been translocated from their natural range. The population eventually declined to 51 birds, but the worst for the Kakapo was over. Continuing to the present day, attempts to conserve for all the remaining birds, of which all were named, has been a long and tiring process, but which has been undeniably incredible. Every bird receives their own individual health check, and eggs and chicks are hand-reared to encourage birds to make more eggs, to breed more, and therefore increase the population in a faster way. A model kakapo known as Chloe was even made in being the first attempt to collect kakapo sperm for artificial insemination, but this attempt wasn't so successful. The kakapo population today numbers 211, and while low and still being critically endangered, the future of the kakapo is looking brighter than it ever has before. Because kakapo went through a genetic bottleneck in which the population was reduced significantly, birds are inbred and thus have low genetic diversity. This has become apparent in recent years as birds face lower disease resistance and fertility problems, with around 40% of all recently hatched eggs being infertile. To amend the latter issue, kakapo are routinely moved around to ensure that different males mate with different females, so that the population is more varied and at less of a risk of being infertile. In having such low genetic diversity, it was a large problem when a fungal disease known as aspergillosis was discovered in kakapo, with almost 20% of the population or 36 birds being flown by helicopter to veterinary hospitals around New Zealand for CT scan diagnosis and intensive treatment, a process that's usually lasted for several months, with 2 birds currently under care. In total, 9 kakapo were killed by the infection, and in the future, the lessening of such diseases will be critical if kakapo are to survive without human intervention. The long-term goal for the kakapo recovery program is to establish at least one viable, self-sustaining population of kakapo, and to meet this challenge, Resolution Island has been prepared for kakapo reintroduction, with the eradication of stoat being a vision for the future, bringing the kakapo conservation tale full story from where Richard Henry once made the first attempts to save the birds. The conservation story of the kakapo is one of the most inspiring out there, and shows that even when the odds of saving a species seems impossible, there is always hope for the future, and the outstanding efforts of the kakapo recovery team are an instrumental part of bringing these beautiful birds back from the brink. I thank you for watching this rather long instalment of New Zealand Bird of the Week. For next time, you are now able to vote for the black-fronted tern, an endemic bird that is commonly seen around braided rivers and coastlines. And with that, I'll see you next time, whenever that may be, and be sure to check out the sources provided in the description, as they have a lot more in-depth information on kakapo